Okay, this is the second video for Solutions, Chapter 13. Left off the last video doing an example um, solving for molarity if I have moles and liters, and then I changed it up a little bit by having grams and liters. And since I had grams, I had to convert grams into moles so that I could use the molarity equation. Um, Another possible kind of way to switch it up is instead of giving you liters, I could give you milliliters. Um, so I'm going to do a little bit different question here. Let's see. If we have 200 exactly, 200 dot milliliters of solution, and the molarity is 2.7 molar, how many grams of, let's see, let's do NaCl again. Did we use? So, if I look at that question, I have milliliters, I have molarity, I'm looking for grams. Well, there is no equation up here that has grams, but I know if I can get moles, I can convert moles into grams. So this is the equation I'd want to use because I'm looking for grams. I don't have grams, but I know if I can get moles, I can always convert moles into grams. So I'm going to use this equation, mole equals L times M. Now I have M is 2.7, I can plug that right in. The problem is I don't have liters. What I have is milliliters. And 1 liter equals 1,000 milliliters. Now you could set up a conversion and convert, but this is the metric scale and it's nice and easy to convert from one unit to another because it's metric, it's 10 based, and it's just a matter of moving the decimal place. Now if I have milliliters, in this case I have 1,000 milliliters, and I want to convert it into liters, all I do is I take the decimal point, which is right here, and move it over 1, 2, 3 places. If I move it over 3 places, that 1,000 becomes a 1, and that converts it into liters. So I'm going to do the same thing here. To go from milliliters to liters, I just move the decimal over 3 places. 1, 2, 3. So what I end up with is 0.200 liters. And now I can plug that in here. So 0.200 liters times the molarity, which was given to me in the question. I didn't have to do any extra work for that one. Do that math, and I get, should really have my calculator closer, 0.200 times 2.7 equals 0.54. And if I think about this, if I remember, moles is the same as moles over liters. So it can actually be helpful to write it moles over liters. Because now I can see what this L and that L are going to do. That L and that L cancel. The only unit left is moles. And that's the unit on our answer. So now that I have moles, and we're getting close to the answer, but the question is asking for how many grams, not for how many moles. So I got to do that last step of converting my answer here, moles, into grams, so I get my final answer. And do that, 0.54 moles times blank line, mole, starting unit always goes on the bottom, grams is what we're looking for, goes on top. Mole in grams, mole is always 1. Grams, I have NaCl. So I'm going to take 1 Na and 1 Cl from the periodic table, and I use that in the last video. Still have my answer here, 58.44277. So I do that math. Starting number times top number divided by the bottom number, and I get, let's see here, 4277, 31.559 dot dot dot. Keeps going. Well, I got 2 sig figs here. And actually I should talk about that here. When I get the moles up here, this has 2 sig figs, this has 3 sig figs, so my answer should always be with the smaller number of sig figs, so 2 sig figs. So 2 sig figs here, 2 sig figs here, that means my final answer is 32 grams of NaCl. So in the practice quiz, there's quite a few questions like this where you're using a fairly simple equation, but there's going to be these side calculations, like doing a grams to moles or moles to grams or liters to milliliters or something like that. So if you have any questions on those, be sure and stop by. The next type of question, we just did one of these. The next type of question I want to do is a dilution question. And our dilution equation is this. I'm going to pause this a second and write out a word equation. Oftentimes dilution questions will be a little wordier. It's more like a situation that you're explaining and you have to set it up from that word equation. So 1 second. Okay, this is kind of a basic dilution question. And one hint that it's a dilution question, and it's different from the other questions that we've done so far, is that if you notice, we've got 3 numbers. We have a volume here, we have a molarity here, and we have another volume here. So that's one hint that it's going to be a molarity question, or a dilution question. Because with dilution questions, we know that we have 4 variables here, M1, V1, M2, V2, and one of them will always be missing. So we'll always have 3 out of the 4, and we'll be looking for that missing 4th variable. The key to these questions, I think, is figuring out which number is which variable. And you'll have to kind of read the question and kind of understand the context of the question. So it says, if we have 700 milliliters of 3.0 molar HCl and dilute it to 1300 milliliters exactly, what is the new molarity? So the first thing I'm going to do is I'm going to go through and I'm going to go figure out which numbers are which variable. Well, milliliters, I know milliliters is a volume, so that's one of my V's. And here's another milliliters, so that's my other V. Here I have molarity, so I know that's one of my M's. And it says what is the new molarity, so I'm looking for a molarity. So that's going to be my unknown thing that I'm looking for here. Now it's got to figure out, is this V1 or V2? Well, if we kind of read the question, the context of the question, it implies that we're starting with this. So we have this much HCl and we're changing it to this much. So this is my starting volume. And if we notice, we have this volume of this molarity. So since it's this volume of that molarity, those two are related. They're talking about the same situation. So they have to have the same little number. You can also think of it as this is my starting molarity, because it says what is the new molarity? Well, new molarity kind of implies what we're ending up with. So M2. which means this is V2. So we have V1, we have M1, we have V2, and we're looking for M2. So the first thing I'm going to do is I'm going to rearrange my question or my equation. So I have M2 alone. I'm looking for M2. So I want to get M2 alone. To get M2 alone, I'm going to need to divide by V2. Got to do it to both sides. That V2 and that V2 cancel. I'm left with an equation that says M2 equals M1 times V1 equals V2. And I know all those things. I think it can help a lot to kind of write, when you're doing this on paper, write the symbols, the variables, right by the number. So M1, I know that's 700. Times, oops, that's not 700, sorry. M1 is actually 3.0 molar times 700, because V1 here, milliliters, divided by, that was sloppy, V2 on the bottom, and V2 I know is 1300. I really wish this thing had an eraser. So I do that math. I do 3.0 times 700 and then divide by 1300. And with sig figs, I got 2 sig figs here, I got 3 sig figs here, I got 4 sig figs here. You always got to go with the smallest number of sig figs, so 2 sig figs. My answer should be 1.6. If I notice the milliliters and the milliliters cancel here, the only thing left is molar. 1.6 molar. And that makes sense because I was looking for a molarity. The question's asking for a molarity. So you could have these questions where you have 2 molarities and only 1 volume, and you're looking for that missing volume. There's a lot of different variations, but the basic concept is the same here. Figure out that it's a molarity or a dilution equation. Figure out what the variables are. Figure out what the missing one is, and then rearrange your equation for the missing one and plug in the numbers for the rest. One thing I want to point out here is for molarity, so for M equals moles over liters, we always wanted liters. Here, if you notice, we had milliliters, which is okay because what did they do down here? They just cancel out. So you might actually get a question sometimes, possibly on the practice quiz, where one of these is milliliters and the other is liters. Well, if we set that up down here, they wouldn't have canceled. So you'd have to convert one into the other. It wouldn't matter which. You could convert liters into milliliters or milliliters into liters, as long as they're the same, so that when you do the math, that they cancel out. And it doesn't matter if you have milliliters or liters. They just have to be the same so that they cancel. That's about it for the math part of this unit. The rest of this stuff is notes. There are a couple examples with the parts per million, the percent concentration, so look those over. It's not a huge part of this unit, but you'll want to look those over. And the rest is vocab. If you have any questions, I have paper versions of all this stuff, like practice quizzes, worksheets, stuff like that, if you want some additional practice. If you're having trouble with the practice quizzes, remember, practice quizzes are very similar to the tests. So if you're not getting the practice quizzes, come in, get some help on those off days. And yeah, send an email, stop in if you have any questions. See you later.